Okay, so quick going over this review sheet. I know we already talked about numbers 1 and 2. The two limit definitions, one of them is the official limit as h approaches 0 of f of x plus h minus f of x over h. The second one is just basically slope. It's a limit definition that looks like slope, and it's not used as much in practice, so you probably aren't used to seeing it, but it's pretty much this, which it looks like slope. It looks like, you know, a y minus a y over an x minus an x, and that is your second definition. Number 2, give 4 instances when a function is not differentiable. Well, just think about a graph and think about drawing tangent lines, because differentiable means it has a derivative. If it has a derivative, it has a slope. If it has a slope, then you can draw a tangent line that has a slope. So tricky things are going to be like holes, asymptotes, endpoints, and sharp turns. All of those are discussed in class and part of the tricky stuff. And now we get to actually start. Okay, number 3, evaluate using the limit process to find the derivative. Okay, so on these 3, or actually maybe it's just these 2 that you're supposed to do that. Okay, so on this one right here, if we're doing the limit process, then I'm going to just come up over here and do it. We're doing the limit as x approaches h, or I'm sorry, as h approaches 0. It's supposed to be f of x plus h, which means if it's f of x plus h, you're going to recopy the -5, but in the place of x is an x plus h. And then it's minus f of x. Notice the double negative there. And this is what you're doing. So if you distribute the numerator, we've got -5x minus 5h plus 5x over h. And notice things are going to cancel, right? -5x cancels with a positive, and you're just left with -5h over h. That reduces, and the answer is -5. Okay? Now, number 4, it's the same kind of a thing. See, 1 minus x squared. I'm going to do the same thing that I did for number 3. It's just a little trickier. So in the place of h is going to be an x plus h, and then minus, now I need to recopy the original f, and so this is what I'm doing. So this is going to be a little worse because you're going to have to FOIL right here. Okay, so I'm going to FOIL, that's h squared plus 2xh plus h squared. I'm going to go ahead and distribute this negative while I'm at it over here on this side. -1 plus h squared all over h. Okay, so and then keep in mind there's a negative in front of these parentheses, so if I want to drop the parentheses, I need to make this a positive and then change all the signs in here. So negative, 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 and now I can drop my parentheses. Okay, and now let's simplify. Right here I've got a +1, -1. Oh, that's not a 1, that's an h. Haha. Okay, here's a +1, -1. I've got an x squared and a -x squared. And now with all of this that's left, do you see how every term has an h? Well, that's supposed to happen because if you factor out that h, it's going to look like this. Okay, -2x minus, that's a minus, h. And then we're going to cancel the one on top and bottom. And remember, out here in the front, it's the limit as h goes to 0. So this is the part where you get to plug the 0 in for h. And so -2x will be your final answer. Okay? All right, so those are the hard ones. Now we get to the quick shortcut derivatives. So number 5, it's giving you a function, and it wants to know f prime of 4. So what does this actually mean? Well, it means take the derivative and evaluate it when x is 4. So it's a 2-part problem. You need to do a derivative and then you get to plug it in. So it won't be too bad. Now I will do this first. Before I take a derivative, I'm going to rewrite this over here in a good form for shortcut derivatives, because remember, you know, stuff like this and this, those are hard to deal with. So 2 over x squared is the same as x to the negative second. So you want to rewrite this first. The same thing in the back, 6 times the square root of x, write that as 6x to the 1/2. Now that you've rewritten it, now let's take a derivative. So for the derivative part, so f prime of x, I'm going to do all of my rules. There's a 1 there, bring that to the front, subtract by 1. Remember, a constant goes away. This is going to become minus 4x to the negative third, and this will be minus, 6 times 1/2 is 3, and then subtract 1 from that. Okay, so this is what I'm looking at. Now, I need to rewrite this so that I can now plug in my 4, because if you plug in a 4 to this, you're not going to understand what it means, okay? But if you rewrite it first, then maybe it'll make sense. So my rewrite, 3 is 3, okay? Now what is this? Well, 4x to the negative third, if I take it back to a fraction, it looks like that. And then this one here, minus, 3x to the negative 1/2, this is kind of a double whammy. A negative exponent sends this to the denominator, but then it also goes back into a square root. It is very important that you know your algebra rules. You've done this the last 2 or 3 years, and if you're rusty, you need to really practice them, because you've got to be able to go back into this form when necessary. And on a problem like this, it's necessary because we have to get this so that we can now plug in the 4. So everywhere there's an x, I'm going to plug in a 4, and then I'm going to evaluate. So the 3 is a 3. Okay, it's going to be 4 over 4 cubed, and then minus 3 over the square root of 4. And then from here, you can, reduce and get common denominators. 4 over 64, that would be 1 over 16. And so my common denominator is 16, so I'm going to put everybody over 16. So let's see, 2 times 8, so that's a 24. 3 times, that's over 1. So what's 3 times 16? Is that 48? Okay, so this is my problem. 48 minus 1 minus 24 and over 16. So 47, 34, is that a 29? Wait, it may only be a 19. I don't know, y'all. What's 47 minus 24? That's 23, I think. Okay, something like that. So I'm getting 23/16. Hopefully I mathed that part right. All right, so yay, lots of fun algebra. Now number 6. Let me erase this first because it's already too much. All right, so number 6. Given blah, 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 A, how would you find the instantaneous rate of change at 41? This is the same question as number 5. It's just worded differently. Instantaneous rate of change just means derivative, okay? And in fact, yeah, I don't even have to do the problem because it just says, how would you find this? So pretty much on something like this, I would take the derivative of each term, and then I would plug in the 41. Done. Part B, how would you find the average rate of change? Okay, an average rate of change is more like that definition I wrote at the very beginning of the video. Average rate of change is slope between 2 points. So I would take my x's, I would find the y's that go with them. And after I find the y's that go with those x's, then I would do good old-fashioned slope formula. Okay? All right, number 7, this notation means, take the derivative. So I'm taking the derivative of this. Now, this thing behind it, be very careful because students often get lazy and start to forget that there are rules, and they'll just take the derivative of this, and then they'll take the derivative of that, and then they'll be done. But you're not done. There are 2 functions right here, and their relationship is that they're being multiplied together. This does require a product rule. So I would call that F and I would call that G. Out to the side somewhere, I would figure out what my F prime is. So the derivative of the first part is just 18x to the 5th. And then my second part, I would find g prime. So g prime is, what's the derivative of cosine? Well, it's negative sine, okay? And once I have that, now I need to do the derivative of the first times the second plus the first times the derivative of the second. So this is your product rule, and you're going to plug into that. So f prime is 18x to the fifth. The g, if you just look at your stuff, it's the cosine of x. I'm going to recopy that plus sign. And then f is 3x to the sixth. And then g prime is up here, negative sine x. Now, the negative sine x, you know, it's multiplied with it, so I'm actually going to move the negative part to the front because I don't want it to look like a minus sign in the middle of my problem. So this would be it. That is the answer right there. Okay, number 8, this is kind of conceptual. On the same axis, sketch a graph of the derivative of the given function. Well, remember, if you're sketching a derivative, you're sketching the slope at each point. So how do you sketch a point? Well, it's really not bad at all. The first thing I look for is the top and bottom of my hills, my mins and my maxes. Because if it's a min or a max, if you imagine a tangent line, the slope of that tangent line is 0, so you just take whatever this x value is and drop a point right down to the x-axis. This one has a slope of 0, so I need to go to the x-axis right here at the origin. Now, my derivative graph has to cross through these 2 points. So if you imagine playing connect the dots, it's either a parabola that goes this way or it's a parabola that goes upside down. So how are you going to know which one? Well, it's easier than you think. When you look at this graph and you read it left to right, would you call the slope of this piece positive or negative? Well, I call the slope of that positive, right? You're reading it left to right. If it's got a positive slope, then on the graph, it's got to be positive as well. So where are the positive y's located? Well, the positive y's are up here, so I know my parabola would start like this. And I'm going to go ahead and continue it and then just make sure this works. Okay, now I know it works because if I look at this middle piece right here of the original graph, see how that's going down? Okay, it has a negative slope right here. If I drew a tangent line, that's a negative slope. So on the red graph, I better have negative y values. And lo and behold, look at all of my y values. They're all below the x-axis. And then just to finish out the picture, these match up over here. Positive slope over here, positive y's on the red. So the red graph would be a perfectly wonderful answer. All right, number 9 is going to be a derivative problem. Now, in the denominator, there is only one x term. There's no plus or minus. There's no trigonometry. So I'm going to go ahead and start by not taking a derivative. I'm not going to take the derivative yet. I'm just going to rewrite this problem. So 2x to the 8th over 4x cubed, 3x to the 5th over 4x cubed, x squared over 4x cubed. All right. And I'm actually going to call that x to the 1/2 over 4x cubed. Okay, the reason I do this is because if you go now and just simplify each and every term using your rules of exponents, it makes this easy and doable with the shortcut. So I'm going to shut up and just reduce. That would be 2 on bottom and then x to the 5th on top. This would be a 3/4 and then x squared. This would be a 1/4. And then what is that x? That would be an x on bottom left over, you know. Or you could remember your rules of exponents where you just subtract 2 minus 3 and it's a -1. This, there's no simplifying, but I'm going to write it as x to the -2 so that I can take a derivative. And then this one will be a little trickier. I've got a 1/2 and a 3, so I need to do 1/2 minus 3. And that would be, what's 1/2 minus 3? 3 over 1, that's a 2, that's a 6, negative 5/6. So all of this is just the work that needs to be done so that now you can actually take a stupid derivative. So now I do my rules. 5 comes out to the front, multiplied by the 1/2, and then I reduce the power by 1. 2 times 3/4 is 3/2. Bring that negative 1 out with the 1/4 and then reduce that by 1. Bring that negative 2 out to the front. Is that going to be a negative 1/2? I think so. And then this one will turn positive because it's a negative times a negative. That's a negative 5/24. And then x to the, I'm going to minus 1 again. Alright, so that is your answer, and it's ugly, but that's what I'm getting, and I feel like I did it right unless I just subtracted something wrong. Okay, whew, that was hard. Alright, number 10. Number 10 is not nearly as bad. You've got something on bottom, but now this time you can't split this up and in order to reduce it. It's not going to reduce because that's a sine, and sine's not going to reduce with any kind of polynomial. So you're going to leave this alone, and you're going to go into a quotient rule. The top is f, the bottom is g, and I would always label them that way. And then what you can do is remember your quotient rule. So everybody's got their own little memory tricks. I only know one. Mine is girlfriend prime. I remember girlfriend prime. And girlfriend prime is how it starts, and then I have a minus sign, and then I always know to just flip this. So then it would be an FG prime, and then it's always over g squared, okay? So before we start plugging into this, I know my f, there's my g. I need to know f prime and g prime. So I always take notes to the side when I'm rusty, okay? So what is my f prime? Well, if you just do the top, you're going to get a 10x minus, is that a 32x to the third? Yes, okay. So there's my f prime. My g prime, the derivative of sine is cosine. Okay, so now that I've taken all my notes, now I'm going to put it into my function. So what is g? Well, normal g is what's on the bottom right here. And then times f prime. Now, f prime is this whole thing. So notice my use of parentheses. Now I need an f, so my normal f is that entire thing. And now I need a g prime cosine x all over the bottom squared, g squared. Okay, so this is your answer. I am going to quit because here's the thing. Your teacher may told you like, hey, you're going to want to distribute and you're going to combine like terms. And that's right. But on this one, it's not right because if I were to distribute, I hope y'all notice there will not be any like terms. Like these will all be sines, these will all be cosines, and they don't go together. So I would just leave it just like this. Okay? All right, number 11. We are going to multiply this out. Now you have two options. Now some people would look at that and immediately say product rule. And if you want to do a product rule, you can, you can do f and g and find the derivative of each. I actually notice cosine and secant here, and it makes me want to distribute. Why does it make me want to distribute? Because I know that a cosine and a secant are reciprocals of each other, and therefore they will cancel each other out. So when I distribute the cosine, step 1 looks like this. But then right here, secant times cosine, y'all, that's gone. Secant times cosine is a 1, so it's gone. So just by distributing, this is my new problem, and it's so much easier than doing a product rule. So sometimes you want to look at that and see, can I distribute and make it simpler first? Now we take the derivative. So the derivative of cosine is negative sine. And then the derivative of minus 2 is just 0. So there's your answer. All right, number 12. I am not going to do that in this video because then the video would be 10 minutes longer. So let me know if you need help with that. I believe there's a picture of it out there floating somewhere. and I'll get it to you. So good luck to you, and let me know if you have questions.